Okay, good evening, everybody. I'm going to continue with you here analysis of hinged arches, three hinged arches. We have seen in the previous lecture the analysis of funicular arches, and we solved several problems on that. Today we are going to solve the other types of arches, three hinged parabolic arch. I will start immediately by solving a problem. Take care. This type of arch is not funicular. It means that when you take any section, you will have the three internal forces. So we are using simply the equilibrium equations to determine these internal forces. It says here that we are having a parabolic arch ABCD. It is hinged, and is provided with an intermediate hinge at point B. Of course, we should introduce an intermediate hinge, otherwise we should not be able to solve the problem, because we are having four support reactions and three equilibrium equations. There should be another condition equation provided by the intermediate hinge to add or to let the total number of equations we have is 4, and the total reactions will be 4. So what is required? It is required to determine the support reactions. It is required to determine the moment at point C, the normal force at point C left, and the shear force at point C left, the normal force at point C right, and shear force at point C right. Okay? Solution. Now this is the vertical reaction AY, and remember that the horizontal reaction, since we don't have any lateral loads applied, this horizontal reaction is equal to this horizontal reaction from sigma fx is equal to 0. So I'm going to call it H. Unlike cables, the horizontal reaction at the support should be inward, because the applied forces, they are trying to move point A to the left and point B to the right and point D to the right, and the support is returning them back. So the horizontal reaction is inward, unlike the cables, it's outward. So how can we start? We can either take moments about point A to determine dy, or moments about D to determine AY. So I will say sigma MD is equal to 0, and this is the positive direction. Then I'm having 40 AY minus 30 by 10 minus the resultant of this load is also 30. It is 1.5 by 20, and it is at a distance of 30 foot. From there, you will get the value of AY, and it will be equal to 30 kips. Okay, from sigma, Fy is equal to 0. That's the positive direction. Therefore, dy equals 30 plus 1.5 multiplied by 20 minus 30, which is also 30 kips. So this is here equal to 30, and this is equal to 30. How can we get the horizontal reaction? We can get the horizontal reaction by taking moments about point B, either from the left hand side or the right hand side. I will take the left hand side here. So I will say sigma MB from the left is equal to 0, and this will be the positive assumed direction. Therefore, the horizontal reaction is rotating positive, so it is 15H plus the resultant of the distributed load is 30, and it is at a distance of 10 foot. So it is plus 1.5 times 20 multiplied by 10 minus the vertical reaction multiplied by 20. From there, the value of H would be equal to 20. So this means that this value is 20 kips and this value is 20 kips. So we finished the first requirement in the problem. I want to get after that MC. Take care, let me erase this first. How can we determine the moment at point C? I will cut a section here and we can take either the right hand side or the left hand side. Whenever you want to get the moment at this point or the shear and the normal force, you need to know two things. You need to know this value, HC, and you need to know the equation or the angle between the tangent to the arch and the horizontal, which is theta C. How can we get these values? That's very important, بقى. This is the new thing about the arches. Since this is a parabolic arch, I'm going to assume the origin is located here. This is the y-axis, and this is the x-axis. And this is the equation of a parabola. يبقى you can say that the equation of the parabola equals y equals some constant times x squared. How can we get the constant? By substituting with a point with known coordinate. The coordinate of this point, because I am selecting my axis in this direction and this direction, so this is the origin. It is 0 and 0. And what is the coordinate of point D? He gave us in the question that the y coordinate would be 15 and the x coordinate would be 20. So the coordinate of this point is 20 and 15. So this means that at point D, we are having 15 is equal to k multiplied by 20 square. From there we can get the value of k, and that is equal to 0.0375. Therefore y is equal to 0.0375x square. This is the equation of the parabola. Now, we want to determine the rise at point C, which is the difference between point C and this level type. We can determine from the equation of the arch the value of YC, right? We can say here at point C, we can say here at point C, the value of XC is how much? Since this is the origin, يبقى the value of XC is 10 foot. يبقى therefore YC is equal to 0.0375 multiplied by 10 square. So this is 3.75 foot. Type, I want the rise of point C. How far is point C from the horizontal datum? يبقى therefore HC will be equal to 15 minus 3.75, which is 11.25 foot. Of course, whenever you are given a problem where you are having a parabolic arch, I would be giving you 1 point or the height of 1 point only. For example, this point or that point, and from there you are going to get the equation of the arch. From the equation of the arch, you can determine the coordinates of any other point. Okay? Remember, this is not linear. You cannot say that this distance over this distance equals this over that, because it is not a straight line, it is a curve. So the equation is y is equal to some constant times x squared. If it were linear, then y is equal to k times x to the power of 1. This is the equation of a straight line. But this is a parabola, so it is x squared. What else do I need بقى? Because he told me that he wants to calculate the normal force and the shear force here. I need to get the slope of the tangent to the arch. يبقى I will come here. Since y is equal to 0.0375 of x squared, therefore dy by dx, which is y dash, which is tan theta, because we know from the calculus that the first derivative of any function is equal to tan the angle between the tangent to the function and the horizontal. This is equal to, if you got the first derivative, it will be 0.075 multiplied by x. يبقى therefore tan theta is equal to 0.075x. يبقى therefore tan theta c is equal to 0.075 multiplied by 10, which is 0.75. Okay? يبقى therefore you can determine the value of theta c, and you just substitute in the calculator the value of tan c is 0.75. From there we get theta is equal to 42. (42.97 degrees). Therefore, we knew the rise at point C is 11.25, and we know the angle between the tangent to the arch and the horizontal. Now let us answer the problem. He wants to get the moment at this point, the shear and the normal left of the concentrated load and right of the concentrated load. Let me start with let me start with the moment. Now it is easier that we can take the right hand side. If we elaborate here, this would be the right hand side. We are having this distance is 10 foot. We are having this height, we calculated that already, 11.25. We are having here a concentrated load of 30 kips, and here the reaction 30, and this is 20 kips. Now we are cutting a section here, and we want to get the moment at point C. Of course, we are assuming whenever we are cutting a section, we have to assume the internal forces as usual. So the moment will be assumed to be positive. Take care, because we consider the concentrated load as if you are cutting a section here like this. Okay? This means that I am cutting a section left of point C. So I'm talking here about point C left. Okay, because I'm cutting a section just left of the load. That's why the load is included in the right hand side. Okay? Now we are having normal force. This is normal force at point C left. Again, the normal force should be directed towards the section, because we know in the arches the normal force is compression. Type. We want to indicate the shear. The shear to be positive, it will have to be on my left hand side and upwards. Yes, I am taking the right portion of the arch, but the cut section is on my left. يبقى therefore the positive direction of the shear is like this. This is the shear at point C left. Now I need to solve this. Now at the cut section we indicated all of the internal forces. We can apply sigma fx, sigma fy, and sigma the moment about any point to determine the three unknown internal forces we have. طيب, let me start with the moment. How can we get the moment? We can take moment anywhere, but if we took moment here, the normal and the shear will be included. I want to cancel out their effect, so I will take moments about point C. So sigma MC is equal to 0. Let me take this the positive direction. I will include first the internal moment that I want to get MC. And then the 20 is rotating in the same direction. This is plus 20 multiplied by 11.25. And the 30 is rotating opposite to the positive direction. This is minus 30 multiplied by 10 is equal to 0. From there, the moment at point C would be equal to 75 Gibbs foot. This is moment at point C. Type. Now I want to get the normal force and the shear. Take care. We calculated already this angle theta C, and it should be also this angle, because the angle between the normal force, which is the tangent to the central line, and the horizontal is theta C. Since the shear is perpendicular to the normal force, and since the vertical is perpendicular to the horizontal, yet we are having this angle also is theta C. Now here we can apply sigma fx is equal to 0. Let me consider this is the positive direction. Take care. The normal force and the shear will have horizontal component. I will say NC left cosine theta C, and the component of the shear will be QC left sine theta C, and we are having the 20 Gibbs force minus 20 is equal to 0. And then sigma Fy is equal to 0. I will take the upward direction to be positive. The component of the shear will be QC left cosine theta C, and the component of the normal will be downward, and it will be sine minus NC left sine theta C. The 30 will cancel out with the 30. So you are having plus 30 minus 30 is equal to 0. Now, you can solve two equations in two unknowns, and you can get the value of the shear and the normal force at point C left. If you did that, this will be 14.63, and we can calculate this value. I did not really calculate this in here. We can determine the value of the normal force. If we solved for this one, we can determine the value of the normal force easily from this equation. Okay. Now, this method, we are resolving all of the forces in the vertical and horizontal direction. There is another method, better method, that I want to teach you, where you can get the normal force and the shear force each one at a time, instead of solving two simultaneous equations. The student who wants to work this way, it's fine. And the other method also is another option. It is not obligatory. you can solve with this method that I'm going to explain now. It is easier than solving two simultaneous equations where you can make a mistake. Let us see what am I going to do. Okay. I will draw here the vertical. Now I'm looking to this free body diagram. I'm going to draw the vertical axis and the horizontal axis. Okay? And then the tangent to the arch, which is inclined at an angle theta c, and the normal to the tangent to the arch. So this is the tangent to the arch, and this is the normal to the tangent of the arch. Okay? This angle is theta. So this angle plus this angle is equal to 90, and this angle plus that one is equal to 90. This should be theta c. Leave one and the other will be theta c. Leave one and the other will be theta c. I want you to put on this diagram all the forces that we have. Okay? So you are going to put the 30 will cancel out with the 30. So I don't have 30 here. All what I have is 20. Kip's foot, which is the horizontal reaction. Okay, and for the normal, I am having the normal in this direction, NC left. And for the shear, I am having in this direction, this is QC left. This is the x-axis, and this is the y-axis. Okay, what did we do last time? We resolved the forces in the x, and that's why the normal force had a component and the shear force had a component. We are now having two unknowns in the same equation. So why don't we resolve the forces in the x prime direction along the normal force? In this case, the shear will not have a component. But we should be able to determine the magnitude of the normal force immediately without solving two simultaneous equations. The same thing. Why don't we, instead of taking the summation of forces in the y, I will take the summation of the forces in the y prime direction along the shear. In this case, the normal force will not have a component because it is perpendicular to the direction of the shear. Okay, now let us resolve this. Now, the 20 Kip's force can be resolved in two directions, in the x prime direction and in the y prime direction. So it will have a component like this and like that. Okay, this will be 20 cosine theta c, and this will be 20 sine theta c. Okay, so I resolved this exactly parallel to the x prime direction and the y prime direction. This is a right angle triangle, and I know the value of theta c. The hypotenuse is 20, the adjacent is 20 cosine, and the opposite is 20 sine. Now I will apply simple equilibrium equations. I will say sigma f y prime, sigma the forces in the y prime direction is equal to 0, and I will take this as the positive direction. Therefore I am having QC left minus 20, because this is the positive direction, this force is negative, minus 20 sine theta c is equal to 0. Therefore QC left is 20 sine theta c. Finished. We don't have any other forces. And sigma fx prime is equal to 0. Let me take, this is the positive direction along the direction of the normal force. So I will say NC left minus 20 cosine theta is equal to 0. From there, NC left equals 20 cosine theta c. We know the value of theta c. It is 42.97 degree, as we calculated in the previous slide. Okay? Type. What difference will it make if we are cutting a section just right of point C. Okay, now in this case, one student can take the right hand side as usual, but in this case, the 30 kips force will not show up. Okay, or another student can take the left hand side, which is طبعا difficult. He or she will have to include the uniform load and the 30 kips force. Let us work from the easier. If I want to determine the normal force and the shear force just right of point C, so I will be taking this part only, right? So what will be the difference here? Now I'm talking point C right. Point C right, the 30 kips force is not there. Why again is it not there? Because when you are cutting a section like this and you are taking this part, the forces that will be included is the horizontal reaction and the vertical reaction and the internal forces at point C. The normal force and the 30 kips force is not there. So this is no longer, this is NC right. And this is no longer shear. This is the shear right of point C. Again, the positive direction, because we know that the compression, the normal force is compression in the arches, so the normal force is directed towards the section, and the shear, we assumed it in the positive sense, it will be on our left hand side and upward. The moment is the same as before, because the moment when you are cutting a section here or section here, it wouldn't make a difference because this distance is 0, so it will give you the same result. The moment is not different. The thing that will differ is the shear and the normal force. Okay, so let's go back to this figure here. We are having in this diagram, what will be the forces that I have? The 20 kips force, here it is. Okay, the 20 kips force is included here. And I need to draw the 30. So I will have the 30 kips force as well in this direction. Now the shear is no longer QC left, it is QC right. And the normal force is NC right. Still the same resolution. This 20 kips force will be resolved parallel to the X prime 20 cosine and parallel to the Y prime 20 sine. How about the 30? How about the 30 kips force? Now it will be resolved in this direction and in this direction. Okay? Take care that this angle will be resolved like this. Here we are having this component will be 30 cosine and this component will be 30 sine theta. Okay? And this is directed like that. This direction and this direction. Okay? Now let us sum the forces that we have. So I will say sigma fx prime is equal to 0. Let me take, this is the positive direction. So I will have n c right. What else? I am having this component against the positive direction and this component as well against the positive direction. So I will have, this is minus 30 sine theta c minus 20 cosine theta c is equal to 0. From there, nc right equals 30 sine theta c plus 20 cosine theta c. Okay? And in the y prime direction, sigma fy prime is equal to 0. I will take this the positive direction. Then we are having QC right. The component of the 30 is with the positive direction. So this is plus 30 cosine theta C. The component of the 20 is against the positive direction because it is downwards. Then it is minus 20 sine theta C is equal to 0. From there, the shear will be 20 sine theta C minus 30 cosine theta C. Therefore, again, if you are not comfortable with this method, you can simply consider this diagram, take sigma fx is equal to 0, sigma fy is equal to 0, and the summation of moments about point C is equal to 0, and determine the internal forces. Or, طبعا for the moment, you don't need this diagram, but if you are calculating the shear and the normal force, instead of solving two equations simultaneously together, you can resolve the forces in the y prime direction. You will straightforward get the value of QC because the normal force will not have a component here. And when you take the summation of forces in the x prime direction, you should be able to get the normal force immediately because the shear has no component in the direction of x prime. Okay? In the problem of the three-hinged parabolic arch, the new thing that we learned is how to get the equation of the arch, y is equal to kx square, and tan theta is equal to 2kx. These are the two equations that we need. We need this equation so that we can get the y coordinate of the point, and from the y coordinate I should be able to get the rise. The rise will be 15 minus the y coordinate. And in order to get the slope of the tangent, I will have to use tan theta is equal to dy by dx, which is the derivative of this function, which is 2k multiplied by x, and we can get the value of theta, and we are using shift tan to determine the value of theta. After that, you are applying simple equilibrium equations. We learned something more, that we can use this nice figure to determine the shear and the normal without solving simultaneous equation. If you don't like it, no problem. You can still apply sigma fx and sigma fy is equal to 0 and solve two equations in two unknowns. Okay? In the problem of the arches, you are required to determine the moment and the shear and the normal force at specific points, not everywhere. You are not drawing the diagram. All what you need is to determine the support reactions and the normal and the shear at a given point. Now let me solve another problem with you to make sure that you understood what we said better. As usual, I will be picking a problem from a previous midterm exam. In this exam, it will be required to determine, example, again, find the support reactions and the moment at point B, the normal force at point B right, and the shear force at point B right. It is a parabolic arch with an intermediate hinge. We cannot solve except with this intermediate hinge. And he gave us these distances, 3 meters like that. Here we are having a distributed load of 1 ton per meter and a concentrated load of 5 tons. And here we are having a distributed load of 1 ton per meter. This is point A, B, C, and D. The rise at point C is given 2.5 meters. Again, the reactions, I should have the horizontal reaction inwards. This is AY, DY, and this is H. Okay, solution. We can take moments about point D to determine AY or vice versa. So sigma, the moment at D is equal to 0. This is the positive direction. If I'm having 12 AY minus the resultant of the load is 1 by 6 by 3, the 5 ton force minus 5 by 9, and the resultant of the distributed load is 1 by 3 by 10.5. From there, the value of AY will be equal to 7.875 ton. Sigma Fy is equal to 0. يبقى therefore dy will be 1 by 6, the resultant of this distributed load, plus 1 by 3 plus 5 minus 7.875. So this will give us a value of 6.125. Okay, now we need to get the horizontal reaction. He gave us the intermediate hinge for that purpose. Either that I can solve the left hand side or the right hand side. The right hand side is easier. Then I can say sigma, the moment about point C from the right, is equal to 0, and this is the positive direction. Then I am having 2.5 H minus 6 dy plus the moment caused by the distributed load. It is 1 by 6 by 3 equals 0. From there, the value of H will be equal to 7.5 tons. So we got here the first requirement in the question, the support reaction. This is 7.5. This is 7.875. And this is 7.5. And this is 6.125. What is required from us to determine the moment at B and the normal force and the shear force right of B. Right of B يعني ايه؟ يعني at this section. يعني right of the concentrated load. Okay. Not necessarily because he said right of B that I should take the right portion of the arch. Now I knew from this question that the section is right of point B, but I have the freedom either to take the left hand side or to take the right hand side. Definitely the left hand side is easier. I can solve with it, but when I take the left hand side, the 5 tons will have to be included because the cut section is right of the 5 tons. Type then remains for us, as before, to determine HB and to determine the angle theta B. How can we do that? We will have to use the equation he told us this is a parabolic arch. Yeah, but I will have to use the equation of the arch for that purpose. Okay, we are going to say that y is equal to kx square because it is a parabola. At x is equal to, again, where is the origin? The origin is in the center, like this. At x is equal to 6, y is equal to how much? 2.5. At x is equal to 6 meters, y is equal to 2.5. Therefore, k is equal to 2.5 over 6 square. يبقى this would be this would be equal to 0.0694 square. يبقى therefore xb is equal to how much? It is 3 meters. Of course, it doesn't matter if you substituted -3, you will still square it. So the negative sign will vanish. يبقى this is -3. يبقى therefore yb is equal to 0.0694 times -3 whole square. يبقى therefore hb, what is yb? yb is this distance. This is yb. But I need the value of hb, the height of point B measured from the level of the supports. So this will be 2.5 minus yb. So this is 2.5 minus yb. If you did that, this will be equal to 1.875. Okay, tan theta is equal to 2k multiplied by x, which is 2 multiplied by 0.0694 multiplied by x. يبقى therefore tan theta b. Now substitute x by -3. This will be 2 multiplied by 0.0694 multiplied by -3. Keep the negative sign in the calculator and the calculator will give you a negative angle. Why? Because if we are in the positive quadrant, this slope here is positive. But if we are in the other negative quadrant, this slope here is negative. Of course, we need the magnitude of theta. We don't care about the sign because we know that this angle is measured in the counterclockwise direction, but this one is measured in the clockwise direction. That's why they are having opposite signs. It doesn't matter even if you don't substitute with the negative sign. We just need the magnitude of theta b, and we understand that it is the angle between the tangent and the horizontal. This angle here. Okay? يبقى from there, theta b will be 22.16 degrees. Of course, if you substitute it in the calculator to be negative, then it will give you negative 22.16, but you understand that it is negative because it is measured in the counterclockwise direction, and you should only use its magnitude. Now I will draw my section. I will draw my section here. Here we are having 7.5 and this is 7.875. This distance here is 3 meters and this distance is 1.875. We are having 5-ton force and we are having distributed load 1 ton per meter. The internal forces, always in the arches, there should be normal force compression. So this means that the normal force is directed towards the section. Because it is right of point B, so it will be the shear of the normal force at point B right. طيب, we took the left hand side of the problem, but the cut section is on my right. What will be the positive direction of the shear on my right hand side and downward? يبقى this would be the direction of the positive shear. If this angle is theta, يبقى this angle is theta. What else is missing? The bending moment. We are assuming the bending moment to be positive, so the tail of the arrow is under the datum. Now this is a complete free body diagram. Either that of course we can apply the three equilibrium equations to determine the three unknowns, the normal, the shear, and the bending moment. We can benefit from the nice diagram that we have so that we can solve the normal force and the shear force directly without solving simultaneous equations. So let me show you here step by step how to determine the internal forces. Let us take moments about point B to cancel out the effect of the shear and the normal force. So the summation of moments about point B is equal to 0, and this would be the positive direction. Yep, I am having the internal MB, internal moment MB that I want to get, and the distributed load is rotating in the same direction. So it is plus 1 by 3 by 1.5. The horizontal reaction is also rotating in the same direction. So it is plus 7.5 multiplied by 1.875. The vertical reaction is rotating in the opposite direction. So it is negative 7.875 multiplied by 3 is equal to 0. From there, the moment at point B will be equal to 5.063 meter ton. طيب, instead of solving two equations and two unknowns, let me draw the figure that we are used to have. This is the tangent to the arch, and this is the perpendicular to the tangent of the arch. This is theta. Leave one angle, the other one is theta. Leave one angle, theta. Leave one angle, theta. Let us put all of the forces that we have. In the horizontal direction, we are having here the 7.5. And in the vertical direction, let us add them up. It is 7.875 minus 5 minus 3. So this will be 8 negative, and we have positive 7.875. So this means that we are having a force here of 0.125. How did we get this value? We are having 5 and 3, because 1 times 3 is 3. So we are having 8 downward, and we are having the vertical reaction 7.875 upward. Okay, what else do we have? We have the normal force. This is NB right, and we are having the shear force QB right. Type, we need to resolve the 7.5. It will be resolved in this direction and in this direction. Okay? And we need to resolve the 0.125. It will be resolved in this direction and in this direction. Okay? Therefore, let us apply, this is the x prime direction, and this is the y prime direction. I will say sigma fx prime is equal to 0, and this will be the positive direction. يبقى NB right The component 7.5 is against, and it is 7.5 cosine. So this is negative 7.5 cosine theta b. And we are having this component, the vertical force is like this, so it is resolved to a component in this direction and in this direction. This component is parallel or in the same direction of the positive normal force. So this is plus 0.125 sine theta b. From there we get NB, right? And if you calculated that, you will find that it is negative 6.9. Of course, it is 6.9 ton. It is positive, but it means compression, because we assumed the normal force in the very beginning to be towards the section. يبقى originally we are assuming it as compression force. Okay? And sigma Fy is equal to 0. Let me take the direction of the y prime is positive. يبقى I am having QB, right? And then plus the component of the 0.125. It is plus 0.125 cosine theta b. And also we will have to add the component of the 7.5 because it is in the same direction. Then it is plus 7.5 sine theta b is equal to 0. From there we get the value of QBR, and if you calculated that, it will be negative 3 tons. Negative 3 ton, it means that it is not a positive shear. The positive shear is on my right hand side and downward, but when we calculated that, it is on my right hand side and upward, therefore it is a positive shear. So this is a complete answer for the problem. We solved for the support reactions. When we start solving for the moment and the shear at any point, we will have to get first the height of the point where we want to get the bending moment and the slope or the angle of the tangent to the arch at that point, so that we should be able to get the bending moment and the shear force. Whether you want to use this diagram or not, it's up to you. You can simply use equilibrium of this section or this free body diagram, assume sigma fx is equal to 0, sigma fy is equal to 0, and solve for the internal forces. I believe it is so simple. Now we will have another lecture on 3 hinged arches, but this time it is no longer a parabola. It is part of a circle. All what is different is that we need to learn a little bit more geometry. How can we get this height and how can we get this angle? And the same style will be applied. So it is almost a revision for what we said now, but with a different style to get the geometry HB and theta b. Okay? Thank you very much.